see, this is the exercise that we have done before break. Look, column A and B, these are quite independent of each other and independent of the serial correlation as well. And from these columns, we are not finding any spurious regression. The probability of having significant coefficients is only 5%. And then if you look at column C and D, these are stationary series, and if I am running regression between these, the probability of having significant coefficient is 101 out of 200. This is 50% plus. So there is again spurious regression. And if you are going to this third cell, this is counting this probability of spurious regression. In unit root series, this has risen to 154 out of 200, that is roughly equal to 80%. Okay, so what the conventional wisdom is saying is the spurious regression is occurring because of non-stationarity. If this was true, then there should be no spurious regression in column C and D, because column C and D both are stationary. But because we are finding the spurious regression here, this means this is not the primary cause of spurious regression. What is then the primary cause? The primary cause is primary determinant of the dependent variable should be there. For example, if I am making a regression model for column D, what column D depends on is its own past value, right? So if it is regressed on its own past value, you will not find spurious regression. This is my claim, and now I will show you it actually happens. If you are including the past value of the same series in the model, you will not find any spurious regression. Let me tell you. Here, before column D, I am inserting one more column, and the name of this column is YT minus 1. What I will do in this column, in the front of second observation, I will write the first observation, that will become leg. That is the past value. Basically, in construction of E column, I have used the column, in construction of E3, I have used E2. So E2 should be included as regressor. If this is done, then probably you will not find spurious regression. This is my claim. Let me see what happens. Similarly, in case of unit root, I am inserting one more column, and I will put the leg values here. The first cell is blank, and the observation number 1 should be written in front of 2. I will calculate these regressions again. Okay. So the first regression of, I am not considering IID series again, because it's clear that there is no spurious regression in IIDs. But I will now regress column E on C and D. E is the dependent variable, I will repeat same exercise for the next 3 columns, and just copying the formula, it will automatically shift the cell addresses to adjust for column number F, G and H. These three results are coming from the stationary series, and the next three results are coming from unit root series. Look, I have the regressor. Now regressor is column F and G for column H. The regressors are F and G. So this line list command is writing the coefficients in reverse order. So we will have intercept here, and then this will be the column yt minus 1, sorry, this should be xt, and this is yt minus 1. And same ordering is followed for the next three things. So what should not be significant? I am looking at the regression for y, x should not be significant. I am looking at the coefficient of x and seeing how many times this is turning out to be significant. How I can get idea of being significant? I will design the t statistics and then one more t statistics here. Right? Now I am writing the command equal to if absolute of this thing is greater than 2, it will be significant, it should write 1, and then if not significant, it should write 0. And similarly, and let me make the table. I am counting how many numbers are significant. It's 22. And then for this it's 29. See, for the stationary series, now I have included the right regression into the equation, and because of this, the probability of spurious regression is dropping down from 50% to only 10%. It's 20 out of 200, that is equal to 10%. And in unit root series, the probability of spurious regression is dropping down from 80% to, this is just 15%. This is all what is needed for the for avoiding the spurious regression. Without going into the trouble of applying the unit root and co-integration analysis, you can get much reliable results just by putting in the lag values, and that's all. So this is again motivating us to start building models from the ARDL kind of models, in which you have dependent variable followed by the independent variable and their legs. That's it. If you are doing this, you can reduce the probability of spurious regression significantly. But look, there is a problem as well. Well, I am finding the probability of spurious regression to be 12%, but the nominal significance level is 5%. 12% and 5% are different from each other, right? But the issue is, what will happen if you adopt the co-integration analysis? First of all, you have to test for unit root. In unit root testing, you have to make number of decisions. You have to make decision about intercept. You have to make decision about trend. You have to make decision about augmentations, right? And then you have to make the choice of test. And then when it will come to co-integration, again you have choice of test. You can choose the Johansson co-integration, you can use the Engel-Granger, and you can use the ARDL. And then once you make the choice, then there is again further specification inside the any unit root test. For example, in Engel-Granger you can also include constant and intercept, and without constant intercepts. So there are so many testing procedure after which you will be able to apply the co-integration, right? Every procedure is having 5% probability of type 1 error. If you are making 5 procedures instead of 1, the cumulative probability of type 1 error will rise up, it will go to 20%.